semester review. I'm going to actually start off on number 3 and then come back to 1 because I want you to see the connection between the two. Talk about it in class. So I'm going to take my calculator and I'm going to put in, I've already done this, I want to start over. So I put in x minus 4, x plus 3, and x minus 7 into my graphing calculator y1. I hit graph, and you can see the general shape of what it's going to do. Go up, come down, and go back up again. Now I need to know where those zeros are. So I go to my table and try to find the zeros. Well, there's one, -3, 0. And we saw it's going to come down over here on the right side, and then go back up. So where's that going to be? Well, that's at 4, 0, and at 7, 0. Here's 4, 0, and here's 7, 0. And you can tell from the chart, or from the calculator, it does something like so. Alright? Now, think about those numbers we just did. We said that x was at -3, 4, and 7. Well, let's look up here. X minus 4, if you set that equal to 0, what do you get? +4. Sorry, add them both sides. Silly mistake. Alright? And if you do x plus 3 equal to 0, what do you get? -3. X minus 7, set it equals 0. You get +7. So that's where the connection is between the x-intercepts and these. So number 1 is just going the opposite direction. If we have x-intercepts at x equals 0, x equals 3, and x equals 4, well, we basically want to get this 3 over here. How would we do that? That would be x minus 3, x minus 4, and technically x minus 0, but we just put an x. And a lead coefficient of 1, well, if we take x times x times x, we're going to get 1x cubed. So that's the lead coefficient of 1. If it's a lead coefficient of 2, I'd put a 2 right there. But we don't have that. Now, last step is we have to put in standard form, which means we need to multiply. So I'm going to FOIL first. First, outer, inner, last. I'm going to keep this x and get x squared minus 4x minus 3x plus 12. I'm going to join like terms, -7x. And I'm also going to distribute that x in. So x times x squared is x cubed. X times -7x is -7x squared. And x times 12 is plus 12x. Okay? So you can see this line right here is very similar to that line right here. And that's our answer. So for number 2, 4 comes from x minus 4. -5 comes from x plus 5. Think about this. X plus 5 equals 0. What would I do? Subtract 5. And -2 comes from x plus 2. Now again, I'm going to FOIL. First, outer, inner, last. X squared. You can do any two of them. I like to do the second two first. Personal preference. Plus 2x plus 5x plus 10. Again, I'm going to combine here. I'm actually going to write this one out because now I'm going to distribute the x minus 4 in. X squared plus 7x plus 10. And I'm going to take this x and multiply it by the x squared, 7x, and the 10. And then send this -4 in here, here, and here. So what it's going to give me is x cubed plus 7x squared plus 10x. Now sending the -4 in. -4x squared, -28x, and -40. And now I'm going to join like terms. 7x squared minus 4x squared, and 10x minus 28x. I'm going to squeeze this in on down here. X cubed, 7 minus 4, plus 3x squared, 10 minus 28 is negative 18x, and then the minus 40 just stays. And that is the cubic function that would have zeros of 4, 5, negative 5, and negative 2. Okay, number 4. Now, there's two ways to go about this. If you factor, you can pull out a negative x squared, and then get x squared minus 4. And then the x squared minus 4 would break down to x plus 2, x minus 2. And then what are your zeros? Well, this is going to give you a positive 2. This is going to give you a negative 2. And if you set this equal to 0, that's just straight 0. We can also, unless the problem tells you you have to factor it, you can save some time and use your graphing calculator and put in negative, remember the gray negative key, x squared, wrong button, negative x squared plus 4x squared. And just hit graph. And I did something wrong. Oh, that's supposed to be, I forgot it's x to the 4. Silly me. So let's go change this to a 4. And hit graph. Now remember, when we have a quartic function, we usually get an M shape or a W shape. And we kind of want to get an idea of what those high points are, so I'm just going to go to my table and look. Okay, obviously it goes down pretty fast, but it looks like 3, negative 1, 3, and 1, 3. Those just help me have another little bit of guidance for my graph. So it comes up, goes down, goes back up, and comes back down. And there it is graphed. Okay, write the equation. Now this is doing the same thing. You know, being a W, it's going to be 4. Now, we have negative 4, we have 0, and we have 5. I make my binomials. X plus 4 would give me negative 4. X minus 5 would give me 5. And x out here would give me 0. But the problem is, this is a cubic function. Now remember, cubic usually looks like that. This is a quartic function. So where does that extra come from? Well, think about it. Remember, we talked about this. This is going through, so it has a multiplicity of 1. This is coming up and bouncing, which has a multiplicity of 2. This is going up through, which is a multiplicity of 1. So 5 and negative 4 have a multiplicity of 1, but the 0 has a multiplicity of 2. That's why it bounces. And again, the nice thing about this is you got a graphing calculator. It doesn't take long. You can confirm your answer and know if you got it right before you move on to the next problem. Plug it in. See if you're right. X squared times, parentheses, x plus 4, parentheses, x minus 5, parentheses, graph. And you can look at the table and see, now, this one's drawn to not go down as low maybe as it does in real life, but you do have the general shape of a W. Moving on. Okay, graph this polynomial. So again, let's use that calculator. Let it do the heavy lifting for you. So x cubed, now remember, to the power of 3. And remember, with this calculator, don't keep typing until you move down. Minus 7x minus 6. Use this to confirm. Okay? Now, it says all the possible zeros of the polynomial. But remember, that's where we do p over q. And p comes from the constant, and q comes from the coefficient of the first term. All right? That means we're looking at 6 over 1. So we write them, remember, as plus and minus 1, plus and minus 2, plus and minus 3, plus and minus 6. Now, that's 1, 2, 3, 4, 8 different possible zeros. Obviously, being a cubic function, we're only going to have 3 zeros. And if we look at our graph, we can see where they are. But instead of guessing when we do synthetic division, know what number goes in this box, why don't we use our calculator and find out? So, table. I already know what my zeros are. Negative 2, negative 1, and 3. Negative 2, negative 1, and 3. Negative 2, negative 1, and 3. And you can tell what it looks like right there. Now, what is this y-intercept? Let's see. 0, negative 6. So that's something else I add to my graph. 0, negative 6. And then I saw it just went up a little bit here, down there, and back up so. Now, I get to choose any one of these numbers to put in this box. Negative 2, negative 1, 3. Doesn't matter. I'm going to pick 3. A lot of people do it because it's positive. It doesn't really matter. Now remember, here's what a lot of people did wrong in this problem in class. They went 1, negative 7, negative 6. And that will not end up with a 0 down here. Won't happen. Okay? And that should be your sign. If you get down to there and there's not a 0, something went wrong. So first you check your math. And you end up with not a 0 again. So you go back and realize, oh, wait a minute. I have a cubic function. I have a 1, but I forgot my square, quadratic. I have to have that filler space. Now I'm ready to go. I drop the 1 down. I multiply by 3. Add. Multiply by 3. Add. Multiply by 3, and then I get 0. Alright? Now, the remaining zeros, I have to factor this. So I write x squared plus 3x plus 2 equals 0. This factors to x plus 1 and x plus 2. 2 times 1 is 2. 2 plus 1 is 3. So my other zeros, which I already knew from using my graphing calculator, are right there. Don't forget, this is left out quite a bit. You don't need it here for the remaining zeros, but you need it down here. A big mistake here is to put x plus 1, x plus 2. Now remember, in class I told you a good idea might be to write this one first, so you don't forget it. But that's up to you. But that's the factored form of that cubic. So the degree is 3. That's the exponent. The lead coefficient is the number in front of that x cubed, which is just 1. There's actually no number. Now, in behavior, as we're going this way, towards negative infinity, what's it doing? We can see right here, it's going down to negative infinity. And then, as it's going right, what's happening? Well, it's going up to positive. Y-intercept, we looked in the calculator and got 0, negative 6. Now the solutions, we just write those zeros. Negative 2, negative 1, 3. Negative 2, negative 1, and 3. And you can write multiplicity, you can put m, you can use an arrow, whatever. But notice, on the graph, each one of these is a through. So each one of them has a multiplicity of 1. If it bounced on any of those zeros, we'd have to put a 2. Now, local maximum minimum. Again, a calculator trick. Okay? We pull up our calculator, and we have our graph. Now, we're trying to find what is that high point on the left side in region 2, quadrant 2. So we go to second trace, and we try to find the maximum. Now, we have this little cursor here. We move it to the left of the mountain. Hit enter. Now we move it to the right of the mountain. Doesn't matter where. Hit enter twice, and there's your answer. Negative 1.5, 1.1. Now the minimum. Do the same thing. Second trace. Now go down to minimum, which is 3. Now I've got to move somewhere down here. Now, once I know I'm on the left side of the curve, I can hit enter. But now I just have to hit enter until I get, whoops, that was weird, until I get to the right side. Once I see it again, I hit enter twice, and there's my answer. 1.5, negative 13.1. Again, anything you need to do with the calculator, just check it and rewatch that part and practice it. Okay, number 7. Same thing. I'm going to study all the possible zeros. So here's my P, and here's my Q. That's 4 over negative 1. So basically that's plus or minus 1, plus or minus 2, plus or minus 4. I'll use my calculator. Y equals clear. Put it in. Negative x to the power of 3. Come down. Minus 4x squared. I did it again. Well, that's just going to be a pain, isn't it? How about that? There we go. Plus x plus 4. Graph it. Now it should be an M or a W. Which tells me something went wrong. Well, nope, it's a cube, so sorry. It's going to be a snake. And that makes sense. I don't know where I have 4 stuck in my head, but it happens. Now, find the zeros. Negative 1 and 1. I might as well put them on here while I'm here. Negative 1 and 1. So, I can use either one. No pun intended. Negative 1, I have a quadratic. Negative 4, I have linear, 1, and then my constant. Bring down. Multiply. Add. Multiply. Add. Multiply. 0, just what I wanted. So, x, negative x squared minus 5x minus 4 equals 0. Now to make your life easy, pull out a negative 1. Now I factor. Nope, forget that negative 1. X times x, 4 times 1 is 4, 4 plus 1 is 5. So as you can tell, I didn't go far enough on my graph when I was looking at it because I have a negative 1 here and a negative 4. Those are my 2 other zeros. So let's look at the graph again. Go up. There's my other 0 at negative 4, 0. So my other 2 zeros are right here. I have my original one here, so there's my 3. Factored form. I'm going to start off with my x minus 1 from the magic box. Negative 1 leads to x plus 1, and negative 4 is x plus 4. So I better add this negative 4 over here. I better see if I have a y-intercept. I do at 0, 4. And do I have another ones on the graph? Let's see. Yeah, I do. Negative 2, negative 6. And negative 3, negative 8. So this gives me just a few more points to play with when I'm graphing. Alright? Now, the degree is a cubic function. My lead coefficient, be careful here, it's negative 1. Now, as it's going left, what's it doing? This time it's going up. And as it's going right, what's it doing? Well, it's going down. And what's the y-intercept? We said it was 0, 4. And that's it for this unit. If you need any other help, remember, you can watch this again or go back to this unit's video from earlier semester.